Good morning, everyone. Welcome to English Medium Prep by Exampur, and I'm Kamar Ravi. And I welcome all those students who are preparing for their government jobs. And in this session, we will discuss some previous year's questions which have already been asked in different examinations. And we will also discuss the questions, some more questions from my side. And we will also learn how to solve the question and what is the concept behind the question. All those things we will be covering in this session, so don't go anywhere and just stay tuned with us till the last second of this session. Okay, so guys, first of all I would like to tell you that apart from the YouTube sessions, we also take some paid batches also, and in those paid batches we teach step by step from very basic to the advanced level. Okay, so those students who are very curious to complete the syllabus as soon as possible and step by step, okay, then they must join our paid batches. To join our paid batches, everybody has to download the application. There is an official application on Play Store and you can easily download that. So let me tell you how to download and how to see the courses and how to join the courses at Exampur. Okay, so this is welcome. Okay, now I will discuss how to download the question and what are the benefits of downloading this application. I will discuss a few minutes later. Okay, so let's start with the questions. Actually, let's start with the questions. Okay, so guys, here you can see the question on the screen, and uh, please tell me if you are watching live at this session, then please tell me what will be the answer of this question. Okay, I have already discussed such type of questions in the previous sessions, and these are the very good and very important questions. Okay, and I'm sure that you can solve them. Okay, so what is the correct answer? Please, if you are watching live, then please do comment and do like this session and share among all your friends on social media like WhatsApp and Facebook etc, and please let them know about us. Okay, so that we can have a very big family of English medium students, so that we can study in a very competitive atmosphere, so that we can do our best. Okay, so guys, tell me the correct answer. If an object reaches its starting point while moving, then the final displacement will be equal to the displacement distance traveled. B option is 0, 1, enumeration not possible. Okay, so which one is the correct answer? Please tell. So which one is the correct answer? Please tell me. Which one will be the correct answer? Please tell me. Yes. Which one will be the correct answer? So guys, let me explain that if in this question is starting point moving, then the final displacement. Okay, it means suppose that you have started at this point, and you are just roaming anywhere in this world and then just reaches to this point after some time. Okay, so this is the path. This is the path you traveled upon. Okay, this is the path you traveled upon. So length of this path will be known as distance. Length of this path will be known as the distance. But when we talk about the displacement, then displacement can be defined as the shortest path length between initial and final point. Okay, so the shortest path length between initial and final point, obviously you have started from this point and also finished at this point. It means the shortest path length will be equal to 0. So that's why the displacement of the body will also be equal to 0. Okay, that's why the answer will be B part. Okay, so that's why the answer will be B part. Okay guys, am I audible to all of you? Then please let me know, and if you have any doubt, then you can raise your query, raise your questions. I will try to solve that question live. Okay. So guys, this is the correct answer, and B B is the correct answer here, and we will say that suppose the length of this path is 200 kilometers. Length of this path is 200 kilometers. Then obviously we will say that. This is the distance actually. Okay, so this is the distance. This is 200 kilometers. Okay. So now let's move to another question. The second equation of motion is second equation of motion. Let me take one more example actually based upon this question. Example actually. Let me take one example based upon the previous question. Okay, suppose that this is the home of Mr. Ram. Okay, and Mr. Ram starts moving. Mr. Ram starts moving from this place. Okay, Mr. Ram starts moving from this place in right direction. Okay, it means in plus x direction. And after some time, he just reaches to a shop, mall. Okay, he just reaches to a mall, and he just do some shopping, and then after some time he just return back. Okay, he returned back. Suppose that he returned back like this. Okay, he just returned back like this, and I would say that the path length from this point to this point is path length from this point to this point is 200 sorry 220 kilometers. Suppose that this is 20 kilometers. Okay, yes, suppose that this is 20 kilometers like this. And after some time this man, yes, and after some time and after some time and after so- array, yes, after some time the man reaches to this point. Okay, and the distance and the path and the distance from this place to this place is 5 kilometers. Okay, this is 5 kilometers. And suppose that the time taken time started when he started motion was the time t is equal to 0, and then he reached the mall, the time was is equal to 30 minutes. Time was 30 minutes. Okay, and then after some time, and then he returned to his home, and the time taken by him was 1 hour. Okay, this was actually 60 minutes. Okay, so this was actually 60 minutes. 1 hour. Okay, so when he reached at this place, the time was 1 hour 15 minutes. Okay, 00 seconds. Okay, so this was the time actually. Then now I can raise a question for you to calculate the average velocity and average speed of this man. So average velocity and average speed of this man. Now you can very easily calculate, because this is one of the very simple questions. Okay, so just solve it as soon as possible, because this is not too much difficult question. Okay, so this is 0030 in 00. Okay, calculate the average speed and average velocity. Calculate the average speed calculates the average velocity and average speed. Calculate the average speed and average velocity. Okay, calculate the average speed and average velocity. Now, so what will be the correct answer? Solve. Please solve. Yes, what will be the correct answer? Yes, guys, see, here from this point to this point, when he reached the mall and then returned back. Actually, when we talk about from this place to this place, okay, total distance traveled will be equal to total distance traveled, that will be equal to 20 plus 20 plus 45. Okay, so this will be equal to 20 plus 20 plus 5, and this will be equal to 45 kilometers, and this will be equal to 45 kilometers. Okay, now when we ask for the net displacement is equal to net displacement. Net displacement means the initial position and the final position. So the initial position and the final position, this is 5 kilometers. Okay, so net displacement, that will be equal to 5 kilometers. 5 kilometers. Okay, when we talk about the average speed, then this will be equal to total distance upon total time, and this will be equal to 45 kilometers upon 45 kilometers upon, and this will be 1.25 hour. This is 1.25 hour. Okay, when you divide, or you can take it like 30 actually. Okay, so in this way, calculation will be easy. So in this way, the calculation will be easy actually. Okay, this will be 1.5 hours. Okay, 1.5 hours. So now divide that. And guys, you can just easily calculate the value of average speed, and this will be equal to, speed will be calculated in kilometers per hour. Okay, so by dividing 45 by this, and this comes out to be equal to 30 kilometers per hour. Okay, so this is the average speed. Okay, so this is the average speed. Okay, and this is the average speed. Now, if we calculate the average velocity, then obviously only 5 kilometers has been traveled by this man from initial position to final position. Okay, so that's why 5 kilometers and upon 1.5 hour. Okay, so this will be equal to 5 1 upon 1 upon 0.3, 1 upon 0.3 kilometers per hour, or you can say that 0.33, 3 point, yes, 3.33 kilometers per hour. Okay, so this will be the average velocity. So this is the way we can easily calculate. First of all, we will have to find out the total distance covered by this man, and then we will have to calculate the net displacement of this man. How will you calculate the value of net displacement for this man? And you will have to just join the initial point to the final point. Okay, and then just calculate the length of that path, and that will be the displacement. But in case of distance, you will have to go through all the path he traveled actually. Okay, you will have to measure the whole path on which he traveled. Okay, so in this way we can very easily calculate the distance traveled by this man, and then we can find out the average velocity. And average speed of this man. Okay, so guys, this is the method. So this is the method we can easily calculate. Okay, yes. So guys, now in this question, please find out which one is the correct answer. Okay, so which one is the correct answer? Please let me know which one is the correct answer. Okay, so let me know which one is the correct answer. Which one is the correct answer? The second equation of motion. First of all, you should know about first equation of motion, that is equal to V is equal to U plus AT, U plus AT, okay, and then S is equal to UT plus half AT square, S is equal to UT plus half AT square, okay, and then you have to calculate, you have to memorize it. V square is equal to U square plus 2AS, okay. So here V is U is defined as the initial velocity, suppose that this is a ball and this starts moving with U, and after some time this ball acquires velocity V, and the time taken from this place to this place is small t, okay, and the acceleration of this ball is A, suppose that. So this is initial velocity, okay. So V is the final velocity. This is the final velocity, and A is the acceleration. Okay. A is the final velocity, and T is the time. Okay. So T is the time taken. Yes, initial velocity, final velocity, acceleration, and time, and S is the displacement. And S is the displacement. Okay, so now you can very easily find out that which one is the correct option. So you can very easily find out that which one option is the correct answer. Then obviously you can see that UT plus half AT square, UT plus half AT square, UT plus half AT square. So actually this is the correct answer, UT plus half AT square. Okay, so this one is the correct answer. Okay, so now guys, we must at least we should learn some questions also. Suppose that guys, this is okay, a ball starts moving with 2 meters per second. Okay, a ball starts moving with velocity 2 meters per second, and after some time this ball acquires some velocity. This ball acquires some velocity 8 meters per second is per second. Okay, and the time taken, and suppose that time taken T is equal to 0, and this is the time taken T is equal to, this is the time taken T is equal to, this is the time taken, and this is equal to 0.4 seconds. 0.4 seconds. Okay, so this is seconds. 0.4 seconds. It means the time taken by this ball to gain this velocity changed from 2 meters per second to 2 meters per second to 8 meters per second is 2 meters per second to 8 meters per second is what? Yes, this is what? 4 seconds. Okay, now you can just you can find out this very easily. You can find out this very easily. You will have to calculate the acceleration. Okay, you will have to find out the acceleration, and you have to find out the separation between these two positions. It means you will have to find out the displacement also. Okay, so this is the option. Okay, so example, this is the example. Okay, now find out. Okay, so find out the value of acceleration. So first of all, we will use the first equation of motion. We have been given the initial velocity, and we have been given the final velocity as well as the time. It means the change in the velocity will be equal to the increase in velocity. Increase in velocity, it means 2 meters to 8 meters per second. It means there is the increase in velocity is 6 meters per second. 6 meters per second. And suppose that if the velocity had decreased, if the velocity was decreased, suppose that 8 meter per second to 2 meter per second, it means the change in the velocity would have been 2 minus 8. It means minus 6. minus 6 meters per second. Then here we can see that the change in the velocity is 6 meters per second. Okay, and the time taken by the ball is 4 meters per second. So this is rate of change of velocity. So rate of change of velocity, this is known as acceleration. Rate of change of velocity, rate of change of velocity, and this will be equal to, and a, and this will be equal to 8 minus 2 upon 4. 8 minus 2 upon 4, it means 6 by 4, it means 3 upon 2. Okay, 3 upon 2 meters per second square. So this is the acceleration. Okay, actually this is the acceleration. Here the acceleration is positive. Here the acceleration is positive. If the acceleration of a body is positive, then you can say that the velocity of the body is continuously increasing. If the acceleration of the body is positive, then you can say that the body is continuously, the velocity of the body is continuously increasing. Okay, so when we talk about the displacement, then displacement can be calculated very easily. Displacement can be calculated very easily. There are we can use the both methods. Okay, we can use the both methods. So by second equation, okay, by second equation we can also calculate. By second equation we can also calculate, yes, s is equal to ut plus half at square. Okay, so s will be equal to u means 2 into t, yes, time taken is 4. Okay, plus half a is 3 by 2. Okay, 3 by 2 into t square means 4 square, it means 4 into 4. So guys, here you can say that this 4 will be cancelled by this 4. Okay, 2 into 2 and 2 into 2 will become 4. 2 into 2 will become 4, and this 4 will cancel, this 4 will cancel out this 4. Okay, so the displacement will be equal to 2 4 ja 8, and this will be equal to 8 plus 3 4 ja 12. Okay, so 3 4 ja 12, and this will be equal to 20 meters. So this will be equal to 20 meters. Okay, now, so this is the displacement. We can calculate it by the third equation also. Okay, so we can calculate it by third equation also, very easy. Okay, so you can see here by third equation. Okay, so by third equation of motion, guys, you know the third equation of motion, that is v square is equal to u square plus 2as. Okay, so v square plus u square plus 2as. So yes, and you can see here v square is equal to u square plus 2as. Okay, then obviously v has been given as 8 meters per second. It means 8 square, and this is 2 square, this is 2 square, and this is plus 2 into 3 by 2, 2 into 3 by 2 into s. Okay, so here this is 64, this is equal to 4 plus, okay, so this 2 will be cancelled by this. Okay, and 3s. Okay, so this will be equal to 3s. Yes, this is 64 minus 4, and this will be equal to 3s. So here we can easily calculate the value. 3s will be equal to 60. So 3s, this will be equal to 60. It means s will be equal to 60 upon 3. So this will be cancelled out by 20 times. So s will be equal to 20 meter. Now friends, you have already calculated the value of displacement is equal to 20 meters. Now by using the third equation, you can also find out this value, and the same answer has come. Okay, and the same answer has come, and this is the correct answer. Okay, if you have any doubt, then you can raise your question in the comment box, and I will give you the solution for that. Okay, so this is the method, and these are the questions. Please note. Yes. So this is the question. Guys, I will ask you one more question. I will ask you one more question, and that is also very important question actually. That is also very important question, and that is from the braking distance. Guys, suppose that you are driving, you are driving a car, and you just see a dog. You just see a dog. Okay, you just see a dog on road, and you just had to have to apply the brakes so that dog can be saved. Hmm. Okay. Then when you apply the brakes, then you see that that your car has covered some distance. Your car has covered some distance. Okay, your car has covered some distance before coming into the rest. Then that distance is actually known as. Then that distance is actually known as. That distance is actually known as the braking distance. Okay, so I would tell you the concept of braking distance. Okay, so I would tell you the concept of braking distance, and what will be the concept of braking distance. Okay, how will you calculate the distance covered by the car before coming into the rest. Okay, so suppose that this is a car. Okay, suppose that this is a car. Suppose that this is a car. Suppose that this is a car. Okay, and this car was moving, and this car was moving like this. Suppose that this car was moving like this. Okay, so this car yes, this car was moving like this. This car was moving like this. Okay, and this is the path, and after some time this car come into the state of rest. Okay, so this car come into the state of rest. Okay, so this is the velocity. So this is the velocity. Suppose that so this is a car actually. Yes, this is a very fit car. Let me replace this by this housing, and this one is looking good. This one is looking good. Yes. So this car is going with, suppose that 8 meters per second. Okay. And after braking, after applying the brakes, it comes into the state of rest. Okay. It comes into the state of rest. Then obviously this car has traveled from this position to this position, and this will be known as the braking distance. Okay. So this will be known as the braking distance, and this braking distance will be equal to TS. Okay. So this will be the braking distance. Now, so this is the braking distance. Suppose that if we talk about the, suppose that if we talk about if we talk about the retardation. Okay, so this is the retardation. Okay, so this is the retardation, and this is denoted as A. So this is the value of retardation. Now you will have to calculate the retardation. Suppose that the mass of this car has been given and the braking force are applied, braking force are always opposite to the braking force are always opposite to like this. Okay, so these are the braking force, and braking force is equal to F. Okay, and braking force, so braking force are given as braking force, this is equal to 2 kilonewton. Okay, and the mass of the car is equal to mass of the car is equal to 200 kg. Suppose that 200 kg, 200 kg. Okay, and this is the mass of the car, and this is 200 kg. And calculate the braking distance. Calculate braking distance. Calculate the braking distance. Calculate the braking distance, and this is equal to like this. Okay, so calculate the braking distance. Yes, calculate the braking distance. Now, so what will be the method? What will be the concept that how can we calculate all these things? Guys, we all know that the second law of motion. What is the second law of motion? If a body is moving, and if we apply some force on the body, then the velocity of the body will increase. It means the body will accelerate. If the body will accelerate, then obviously we can find out the acceleration of this body. And suppose that if the body is moving and we apply brakes on the car, we apply brakes on the body, then obviously the velocity of that body will decrease with time. Then the velocity of that body will decrease with time. It means we can also calculate the retardation of the car. Retardation means the rate of decrease of velocity. This is known as the retardation of any body. Okay, this is known as the retardation of any body. So here we will have to find out the retardation, because the car is approaching the zero velocity state. It means the car is approaching to the rest state. It means we will have to find out the retardation. So first, by using the second law of motion, so by using second law of motion, okay, so by using second law of motion we can calculate the retardation, and that will be equal to F is equal to m into A. Okay, that is F is equal to m into A. So yes, this is F is equal to m into A, and F is, what is F? F is equal to 2 kilonewton. This is 2 kilonewton. 2 into 10 to the power 3. 2 into 10 to the power 3 Newton. And mass, and what is the value of mass? Mass is 200 kilograms. 200 kilograms. And A is, what is A? You can calculate the value of A. Okay. So here we can easily calculate that this is 2000 and this is 200. Obviously the value of A will comes out to be equal to A is equal to 10 meters. 10 meters per second square. Okay. So the value of retardation is 10 meters per second square. The sign will be negative actually, because the velocity is continuously changing. The force applied is in the opposite direction to the motion. That's why F will be equal to minus. F will be equal to minus. Okay, so that's why we can calculate the acceleration, I mean retardation, very easily, and that will be comes out to be equal to, A equal to 10 meters per second square. So hence the braking distance, it means a final velocity. So final velocity, that will be equal to 0. Okay, so this will be equal to initial velocity. It means u. Okay, so this is u. So we can calculate v square, and this is equal to u square minus 2as. Okay, so this is this. Okay, so this is actually nothing but the 0 square, and this will be equal to 8 square. This will be equal to 8 square. Okay, this will be equal to 8 square minus 2 into a means, yes, a means 10. Okay, so a means 10 into s. Okay, so a means 10, and this is equal to, and this will be equal to 0, and this will be equal to 64 minus 20 into s. Okay, so s will be equal to 64 upon 20. Okay, so s will be equal to 64 upon 20, and this will be equal to 2 10 20 and 2 30, and this will be equal to 3.2 meters. Okay, so the correct answer will be 3.2 meters. It means the car will be come into the state of rest after traveling 3.2 meters only. Okay, so this will be the very good braking actually, but this will be a very hard braking. So such kind of braking are known as the hard braking. Okay, such kind of braking is known as the hard braking. Such kind of braking is known as hard braking. Okay, so in this way we can learn some very good questions actually, guys. Question number 3: when a hanging carpet is beaten with a stick, the dust particles comes out from it. A option is due to inertia, due to surface load, due to the motion of the stick, due to the concentration of dust particles. So which one will be the correct answer? Please tell me. Which one will be the correct answer for me? Please tell. Yes, guys, actually this is just because of inertia. This is just because of inertia. So A part will be the correct answer. A part will be the correct answer. Okay, you can say that A part will be the correct answer. A part will be the correct answer. Okay, due to inertia. There are some more questions. Okay, cricket player moves his hands back to catch the ball coming at high speed. Always mention one thing, that Mahendra Singh Dhoni also do the same in cricket ground when he is a wicket keeper. Okay, so cricket player moves his hands back to catch the ball coming at high speed. So suppose that let us first discuss some question. Actually, we should take an example. Of this, and we should take an example like this. Suppose that this is the man. Okay, and he is a cricket player. Okay, he is the cricket player. Suppose that the ball he just catches. Ball which is coming with the velocity. Okay, ball which was coming with the velocity like this. Yes, ball which was coming with the velocity, suppose that 200 meters per second. 200 meters per second. Okay, 200 meters is very jada. So we must take as suppose that oh, 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 40 meters per second. Suppose that 40 meters per second. Okay, so the velocity of this ball right now is 40 meters per second. We should take as the actual data. Okay, and the mass of the ball is, suppose that the mass of the ball is 250 grams. Okay, so 250 grams. So this is the mass. Okay, so this is the mass and this is 250 grams. Okay, and suppose that when we talk about yes, when we talk about the ball to be in catch. Okay, when this man catches this ball, when this man catches this ball like this, then obviously he just do this ball, he just catches this ball like this. Okay, he just catches this ball like this, he just catch this ball like this. Okay, he just catch this ball like this. Okay, so now the ball is in his hands, now the ball is in his hands. Okay, so this is the ball. Now you can say that the ball is in the state of rest, ball is in the state of rest now. Okay, so the time taken from this time taken by this man to just time taken by this man, time taken by this man so that he can the catch, he can completely catch this ball is equals to the time taken by this man is equals to, suppose that this is uh, zero point 0.5 seconds or 2 seconds. Suppose that this is 2 seconds. Okay, suppose that this is 2 seconds. Okay, suppose that this is 2 seconds, because when the ball comes in his hands, then after he just starts moving his hands back. Okay, then at this point the ball come into the state of rest. It means the time taken by this ball in coming to the state of rest is equal to 2 seconds only. Okay, so hence we can here say that the ball had a momentum at this point, ball had a momentum at this point very high. Okay, very high momentum, but after some time, as the time passes, the momentum of this ball becomes equal to 0. So we can say that the okay, initial momentum initial momentum initial momentum pi, and this will be equal to initial momentum, this will be equal to initial momentum, that will be equal to m into vi, and this will be equal to, yes, and this will be equal to and this will be equal to 250 grams. 250 grams means 250 upon 1000, 250 upon 1000 multiplied by 40 meters per second. Okay, so this will be the correct answer. Okay, this will be the initial, and the final momentum, this is pf, and this becomes equal to m into vf, and this is equal to, and this one is equal to and this one is equal to this one is equal to this one is equal to m into 0. M means 250 by 250 upon 1000. This is kilograms into 0, because the velocity has comes out to be equal to 0. So this is the final momentum. Okay, so here we can see that the change in linear momentum is equal to 0. Change in momentum, this is delta p, and the delta p will be equal to delta p will be equal to delta p will be equal to like this. Okay, so when we talk about the delta p, then the delta p, this will be equal to 0 minus 0 minus 250. Yes, 250 upon 1000 into 40. Okay, so this will be like this, and 1 upon, and this is 1 upon, and this is 1 upon time, and this is 2 seconds. Okay, so here this will be the correct answer. Now you can just see that this cancels by 20 times. Okay, and this 20 and this 20 get cancelled by this 50 times. Okay, and then this 50 and then this 50 cancel this by 5 times. Okay, so this 5 times, and this will be equal to minus 5 Newton. Okay, so this will be equal to minus 5 Newton. Here minus 5, minus sign shows that the direction, that the force applied, direction of the force applied actually. So here 5 Newton is the force which has been applied by this ball on the palm of this man. Okay, so this is the hurt actually. Okay, so this man get hurted, actually. So we can say that, and that's why. And suppose that when he had taken, suppose that if he had taken, okay, so this is the force applied by, yes, 5 Newton actually, 5 Newton. So this is actually this is the force 5 Newton per 5 Newton which has been applied. Okay, this is the force which has been applied by this ball on the man's hand. Okay, suppose that this man had taken, this man has catched this ball instantly. Okay, if the delta t, okay, if the delta t was very small, if the delta t was very small, then okay, suppose that this man has taken this catch like this catch. It means that time taken by this ball in coming to the rest of his state is that will be equal to delta t very small. Okay, if delta t is very small, it means this is very small. Okay, this is very small, and then this is very small, then obviously delta t, suppose that assume delta t will be equal to zero point 0.1 seconds, then obviously that change in linear momentum, yes, this is the change in linear momentum, rate of change of linear momentum. Okay, actually we should calculate the rate of change of linear momentum, rate of change of rate of change in linear momentum. Okay, so this is so we should calculate the delta p upon delta t, and this will be equal to minus 250 upon 1000 into 40. Okay, into 40, and into 40 m into v. Yes, okay, and this should be divided by 1 upon 0.1, and then obviously we can easily calculate that this will be equal to 25 times, and this 25, and this 25 actually, yes, this 25 divides this by 10 times, then obviously minus 10 multiplied by 1 upon 0.1, it means this is equal to minus 100. Then obviously you can see that this is 100 Newton. Okay, so if this if this man catches this ball immediately like this, okay, then the force applied by this ball on the man's hand will be equal to 100 Newton. But if this man brings his hands back, okay, then the force applied by the ball will be equal to only 5 Newton, and hence this way, and hence if this man catches this ball like this, then this man will not get hurted too much. Okay, and this is the reason, so we actually see that we actually here, so actually we see that the rate of change of linear momentum is actually decreases, because if he catches this ball like this immediately, then the rate of change of linear momentum comes out to be equal to minus 100 newton, or you can say that 100 newton is the magnitude. Okay, so rate of change of linear momentum is equal to the force applied, we all know that, and that's why the force applied has come out to be equal to 100 newton. But in case this man just brings his hands back, then obviously the rate of change of linear momentum comes out to be equal to only 5 newton, and this is the reason that this man doesn't get hurted too much. Okay, so this is the reason, this is the physics behind this practice. Okay, this practice has been done by approximately all the cricketers on the ground. Okay, so please note down this thing, then this is very very important. Yes. Okay, so this is 100 newton. Okay, now let's move another question. Consider the following statements: when the moving vehicle suddenly stops, it falls backwards. Actually, suppose that this is first. Suppose that this is first, and this is second, and this is third, and this is third. Okay, and yes, now what we will have to do: when the moving vehicle suddenly stops, it falls backward due to inertia. This is incorrect. Actually, when the brakes are applied suddenly, then the body will fall in the forward direction, in the same direction which the body was moving, the vehicle was moving. Okay, so gun strikes backwards, cause action reaction. Yes, this one is the correct answer. Yes, this one is the correct answer. Okay, so in sports, a pile of sand is laid on the ground for the high jumper to fall to generate inertia. This one is also incorrect answer. So this one is also incorrect. So option 2 is the only correct answer. Okay, so option 2 is the only correct answer. Please note down. Okay, when a man jumps out of the boat on the bank of the river, when the man jumps out of the boat on the bank of the river, then the boat obviously retraces its path. Okay, when the boat comes out at the bank of the river, then if the man sitting on the boat will want to come out of the boat, then obviously he will push that boat in the backward direction, then obviously he would get some reaction force to move ahead. Okay, so that's why when he just pushes the boat and comes out to the boat, okay, then the boat, if that has not been tied with the rope to the river bank, okay, then the boat will go into the river. Okay, and then obviously it will retrace its path, it will go back on the same path from where it was coming actually. Okay, so that's why the option A is the correct answer. Clear? Okay, now 7. Newton's first law defines that which quantity. Actually, this question creates very much confusion among the students, because whenever any teacher or even myself too teaches the laws of motion, then obviously most of the times teachers just forget to define the force. Okay, so what is the force? What is force actually? When we talk about the force, then force can be defined as the reason so that a body can change its speed, change its velocity. Okay, or you can say that the change its state, either from rest to motion, or motion to rest, or motion to motion at a higher or lower speed. Okay, if the velocity of the body changes like this, from low velocity to high velocity, if the velocity of the body changes from low velocity to high velocity, then obviously you have applied some force. Then obviously you have applied some force on the body, obviously. Okay, so this one will be the correct answer. Hmm. So this one will be the correct answer. So here, Newton's first law of motion will be the correct answer. Newton's first law of motion. Newton's first law of motion defines which quantity? Actually, it defines force. Okay, because according to Newton's first law of motion, it is always said that a body will always try to remain in the same state as it was until and unless we apply an external force. It means force is that quantity which causes the change in the state of the body. Okay, so if the body is moving, then obviously it can stop the body, and it can increase the velocity of the body. Okay, and if the velocity and if the body is in the state of rest, then obviously it can, after applying the force, body can starts moving. And suppose that the body is moving and thus you apply braking force, then obviously the body will come into the state of rest after some time. Okay, so that's why here we can say that the force, Newton's first law of motion is defines the force. Okay, so Newton's first law of motion defines force. Yes, at what angle should a long jumper jump to achieve the longest range in projectile motion? This is a very good question actually. This is a very good question, because this question has already been asked in different examinations, especially in defense exams. Okay, just like CPO and NDA and CDS and NDA and such type of questions. Okay, but this question has already been asked in CPO as well as CHSL also. Okay, so the concept behind is that the projectile formula for the maximum projectile is for the projectile's maximum range. Suppose that this is a ball, and this ball is thrown like this. Okay, so this u is the velocity, so u is the velocity, and the angle, and the angle, and the angle, and the angle, and the angle. Okay, so this is the angle like this. Okay, so this is the angle like this, and suppose that this is the range, and suppose that this is the range, and suppose that this is the range. Actually, when we talk about the range, like this. Okay, when we talk about the range like this, okay, so like this. Okay, ball falls at this point, and this ball falls at this point. Okay, then we can say that this is known as the range. Okay, and this is known as the maximum height. Okay, so this is known as the maximum height. Okay, this is known as the maximum height. Yes, guys. So range. So this is horizontal range. The horizontal distance covered by this ball is equal to is known as the range. Okay, so range, this is equal to u square sine 2 theta upon g. Okay, so u square sine 2 theta upon g, where u is suppose that you have been given whatever with the velocity of u. Okay, whatever with the velocity of u and value of g, the u square upon g is always constant. If this value is maximum, okay, then obviously this range will also be equal to maximum. Okay, so this range will also be equal to maximum. So the value of sine 2 theta is equal to, the maximum value of sine 2 theta is 1, and that is equal to of 90 degrees. So sine 2 theta will be equal to sine 90. It means 2 theta will be equal to 90 degree. and theta will be equal to 45 degree. Okay, so theta will be equal to 45 degree. Please note it down because this is very important thing. So the correct answer is here. So here the correct answer is 45 degree. The correct answer is of 45 degree. Okay. The correct answer is of 45 degree. The correct answer is 45 degree. The correct answer is 45 degree. Okay. Yes. In an object falling freely from zero, have the same speed, have the same force, would have the same acceleration, and none of these. And obviously here would have the same acceleration. If the body is falling freely, then then the body will fall under gravity. Then the body will fall under gravity. Okay, so the body will fall under the gravity. Body will fall under the gravity. Okay, so body will fall under the gravity, and thus C part will be the correct answer. C part will be the correct answer. If the horse starts walking suddenly, then the equestrian, the reason for the possibility of falling is moment of inertia. The reason for the possibility of falling is moment of inertia. Moment of inertia. Moment of inertia. Okay, the reason for the possibility of falling is if the moment of inertia, then obviously the moment of inertia, no, sorry, the moment of inertia will not be the correct answer, and hence the correct answer will be the rest inertia. This is known as the inertia of rest also. If the body is in the state of rest and suppose that the car or any truck or any bus starts moving suddenly, then obviously this body which has been residing on the body, then moving body, then it will just fall down in the backward direction. Okay, so actually this is just because of the rest inertia, because the inertia says that the body will always try to remain in the same state as it was the body, because since the body was in the state of rest, and this is the reason that the body will try to remain in the same state. It means in the state of rest, then obviously in the state of rest and at the same position. That's why if the car or bus or truck starts moving, then the man sitting in the car or bus or truck, then obviously he will just fall down in the backward direction. It will try to regain its original location and position, and that's why the rest inertia will be the correct answer. Okay, so when a moving bus suddenly applies brakes, the passenger sitting in fall in the forward direction. This is just because obviously this has already explained. I have explained this, and this will be equal to the Newton's first law, because Newton's first law is also known as the law of inertia, and this is also known as the law of inertia. This is known as the law of inertia. This is known as law of inertia. Okay, this is known as law of inertia. This is known as law of inertia. Okay, so this is known as law of inertia. The change in which work done by an external force on a system is equal to the change in which the work done by an external force on the system is equal to the kinetic energy. Guys, first of all, you should look like that. Suppose that this is a path, and let me explain on the blank page. Okay, we can see it very very good actually. Suppose that this is a path. Suppose that this is a path, and this is a ball. Suppose that this is a ball. Okay, Suppose that this is a ball, and this ball is and then actually this ball is moving like this. Okay, and then this ball is moving like this. Suppose that the velocity of this ball is equal to, suppose that the velocity of this ball is equal to something 2 meters per second. Okay, something 2 meters per second. Suppose that the body is moving with 2 meters per second, and suppose that now the body is moving with 6 meters per second. The body is moving with 6 meters per second. Okay, so body is moving with 6 meters per second. Now this is equal to 2 meters per second. Okay, now the body is moving with 6 meters per second. 6 meters per second. Okay, and this body is of 1 kilogram. 1 kilogram. And suppose that someone has applied some force, and suppose that someone has applied some force like this. Okay, someone has applied, suppose that someone has applied 200 newton. 200 newton. 200 newton. Okay, so this is 200 newton. Yes, this is 200 newton. Okay, so suppose that 200 newton force is applied, or 200 newton, this is 220 newton. Just take it 20 newton. Okay, so 20 newton will be the good. Yes, suppose that 20 newton force is applied from t is equal to, t is equal to 0 to t is equal to 0020 seconds. Okay, so 00, this is seconds. Okay, it means it takes 20 seconds. Okay, it takes 20 seconds actually. Okay, now guys, you can just calculate. So guys, just calculate the kinetic energy. Okay, calculate the kinetic energy of this body, and the calculate the work done by this force also. Okay, so suppose that guys, if the work is done, by this force, because it does, when this force is applied, this body covers this distance. Okay, so this distance, actually suppose that there is some distance, obviously. Okay, so if the velocity of this body is here is equal to 2 meters per second, and here it is 6 meters per second, then obviously it means you had applied that force, and this force increased the velocity of this ball. And here we can calculate the kinetic energy K1, and this K1 will be equal to half mv square. Okay, so this will be equal to half mv square. This will be calculated as half mv square, and this will be equal to 1 by 2 into m. M means 1 kilogram and v means 2 square, and this will be equal to, and this 2 is equal to, this is equal to 2 newtons, 2 joules. Okay, 2 joules. Now calculate the kinetic energy at the second end. Okay, and this will be equal to 1 by 2 into 1 into 6 square. Okay, so this will be equal to 18 joules. Okay, so the change in kinetic energy will be equal to, like this. Okay, so the change in kinetic energy will be equal to like this. Change in kinetic energy will be equal to like this. Change in kinetic energy will be equal to like this, half K2 minus K1. This will be equal to K2 minus K1. Okay, so K2 minus K1, and this will be equal to K2 means 18 joules. Okay, so 18 minus, and this will be equal to 2, so 18 minus 2. Okay, so 18 minus 2, and this will be equal to 16, and this will be equal to 16 joules. Okay, so this is the increase in kinetic energy. Okay, so this is the increase in kinetic energy, and suppose that you have applied an external force, then this external force some work on this body. Okay, and suppose that the work done by the external force will be equal to, if you want to calculate the distance, the displacement of this body, work done by the force is equal to uh, 20 newton 20 newton into this. Okay, so this will be equal to the change in or the increase in kinetic energy. This will be equal to the increase in kinetic energy. Okay, so this will be equal to the increase in kinetic energy, and this will be equal to increase in kinetic, and this will be equal to 16 joules. Okay, 16 joules. So okay, it means 20 into, it means 20 into s, and that will be equal to 16, and thus by s will be equal to 16 upon 20. Okay, so that's why this will be equal to 0.8 meters. On this will be the correct answer. Okay, so here guys we can see that the work done by the external force is always equal to the increase in kinetic energy. Okay, so work done by the external force is always equal to the increase in kinetic energy, and hence we can say that the external force on the body, that actually increases the kinetic energy, so here, so this will be the correct answer. So here this will be the correct answer. So here this will be the correct answer. Okay, good morning, good morning, good morning. Please just note down. Yes guys, so here just you can just answer very easily. So here you can answer very easily. Okay, so here you can answer very easily. So which one is the correct answer? So which one is the correct answer? The change in which work done by an external force on a system is kinetic energy. Yes, so change in kinetic energy is observed actually. change in kinetic energy is observed. Okay, change in kinetic energy is observed. Okay, so yes, this was the explanation. The SI unit of work is the SI unit. This is actually ERG. Okay, the SI unit of work is actually this is joule, because we all know that work is equal to force into displacement. Okay, so work is equal to, this is Newton. Okay, so this is Newton into meter, and this is known as, and this is known as joule. Okay, so this is known as joule. Clear? This is known as Newton. Work done by an object can be positive, negative, zero, all the three. Yes, D part is the correct answer, because the work done by a particle can also be equal to zero, and it can also be equal to positive and negative also. Okay, so yes, what is the relation between work and power? Yes, what is the relation between work and power, guys? Here you can say that power is equal to work done upon time taken. Work done upon time taken. Okay, so here we can write it as the work is equal to power into time. So A part will be the correct answer. Okay, so A part will be the correct answer. 1 horsepower equals 1 horsepower equals 1 HP, and this is equal to 746 watt. 746 watts. Okay, 746 watts. For the maximum value of work, 6 will be the value of the angle between the force and the displacement directions. Okay, for the maximum value of work, 6 will be the value. Oh, what will be the value of the angle? What actually, this is not the 6 actually. This will be what? What will be the value of the angle between the force and the displacement? Actually, we all know that work is equal to FD cos theta. FD cos theta. Okay, so if work is maximum, so if the work is maximum, if the work is to be maximum, then obviously FD, then obviously cos theta should be also maximum. Okay, we all know that cos theta, the value of the maximum value of cos theta, this is equal to 1. Okay, the maximum value of cos theta, this is equal to 1, and this will be equal to cos 0 degree, and hence we can say that the theta will be equal to 0 degree. So here the option A is the correct, C is the correct answer. Okay, so C is the correct answer. C is the correct answer. Okay. This one is a very good question actually. Here you can say that and you can solve that question. Just solve this question. Okay, so let me take a glass of water. Yes, match the following. Match the following, guys. Here loudspeaker actually, when we provide the electrical signal to the loudspeaker, then loudspeaker changes the electrical energy into sound energy. Okay, from electrical energy into sound energy. So this is the correct answer. Okay, so A, this is for this. Okay, now if we talk about the atomic bomb, okay, from atomic bomb, because when the atomic bomb is gets blast, okay, then the chemical energy inside the molecules gets converted into the nuclear energy. Okay, so that's why the B option will be for fourth. Okay, so dynamo, when we talk about the dynamo, then dynamo, this is the C part. Dynamo actually, which is this is nothing but the small generator. This dynamo is just connected to the wheel of any vehicle, and then when the vehicle moves, the wheel moves, and then this wheel moves, and the dynamo connected to the wheel also moves. Okay, so in this way the mechanical energy get converted into the electrical energy, because dynamo is a small generator actually, from mechanical energy to the electrical energy. So second part will be for that. Okay, now suppose that D part. Okay, when we talk about the D part, okay, so when we talk about the D part, transmitter actually electrical energy signal to electromagnetic signal, because this is the transmitter actually, this is the transmitter. Okay, this transmitter there are some batteries inside this transmitter, and this transmitter converts this electrical signal into electromagnetic signal, and that's why we will say that first part will be for that. Okay, so guys, good morning Atul, good morning Atul. So guys, this I will stop this session for today, and we will have another session at 1 p.m. and so please get ready for that session too, and we will discuss some more questions in the tomorrow marathon class. Okay, we will discuss some more questions in tomorrow's marathon class, and we will have a very good session for that. Okay, we will have a very good session for that. And guys, if you have not subscribed, this channel, then please do subscribe this channel, and share these videos among all your friends. Okay, so guys, let me explain about the benefits of this application, Exam4 official application. So guys, to download the Exam4 official application, you will have to go to the Play Store, and then you have to type Exam4, and then you will find the such kind of logo there, and then you will have to download that application by installing. Okay, just install that application into your phone, and then you will have two options. One is open, and another is uninstall. Then you will have to open it, and then after opening you will see that there are registration and login options. Okay, then obviously you will have to register if you have not registered till now. Then after registering, okay, so when you will type register option, then you will see some options in a form. Then just fill all those things and create a password so that you can log in again. Okay, so after registering here, then back to the login option. Then after login you will have, then you will see there are different kinds of streams for which the classes are being taken by the teachers. Okay, so after after downloading and after watching all these things, you will have to select one or two batches. You can easily download, you want to join that batch actually, and as well as there are some free batches also. You can watch them absolutely free, and you can download the ebooks also. You can have a mock test also. You can join the test series also. Okay, you can get alerts for different kind of job notifications, because we post the job notifications daily basis. Okay, whenever any job comes around or any application form comes around, then we also update that on our portal. Okay, that's why you can see all the job requirements on our portal, and you don't need to go anywhere else. Okay, so this is the benefit of this application. So guys, this is over for today, and tomorrow we will explain some more questions. Okay, so thank you so much for joining us, and have a nice day. Bye bye.